Ihr ruft, dass ich mich sehr viel bewege. Das ist sehr schwierig, ja. Yes. Cool. So let's start, because actually the time schedule is quite tricky, because honestly I thought it's a 15-minute slot, and it's a 5-minute slot. So I will skip the whole introduction about myself. So if you want to know more about me, just feel free to come to me afterwards. I'm here for the rest of today, actually. I'm talking about cultivating architecture in an agile world. And I will try to keep the intro as short as possible, but long enough that you will all understand what I'm talking about. So if you take a look at this title, there are two very interesting things. And the first one is architecture, right? And as so often in software engineering, we really have problems to define things in a way that we all think that we are talking about the same thing, and architecture is a very good example for this, because we don't have a common understanding of architecture, of course, like for many other things. So the first question which you usually ask yourself if you dig into a new tooling, technology, paradigm, what is architecture, right? So what is architecture about? I guess you all know this, of course, or at least some of those definitions, but I cannot talk about cultivating architecture if I don't give you a short introduction what architecture is actually about, right? So the oldest, or one of the older definitions was from Barry and Wolf. You usually find this in scientific papers or very old books, which was, I think, the way how people described architecture back in the days, and it fits to the understanding why this thing is actually called architecture, because it's based on the building architecture, of course. And it says the main subsystems in the system and how they connected together. So that's somehow the obvious thing, right? It's the building blocks and how they interact with each other. The second one, the little bit newer one, which I liked a lot, is the one from Ralph Johnson, where he said the shared understanding of the senior people in a project, right? This is actually somehow true if you think about it. If you go to projects and ask what is really the important stuff here, you usually ask the senior people, and they somehow know it, right? And then I think the most famous or the most common one these days is, of course, from Martin Fowler, the things that are hard to change, right? So those things that are hard to change. I realized, because I saw Fowler a couple of times in the last year at conferences talking about some similar stuff, and he stopped phrasing architecture like this. His new definition is actually the important stuff, whatever that is, right? So even more fluffy, but it is really like this, right? It's the stuff that matters, whatever that is, and how unfulfilling this is to have such a definition. But at the end of the day, you really need to define what is important for your project, what is especially important for your domain, right? So after defining what architecture is, or at least trying to define, as mentioned, I tried to shorten this a little bit. The second thing you need to know usually is why do we actually do this, right? And this surprises me quite often when I ask people why do we need architecture, right? So why do we actually do all this stuff? Why do we do all this documentation? Why do we all do high cohesion and low coupling, all these principles we have in architecture? Why do we actually do this, right? And the thing they usually answer them is because it's our engineering responsibility. And this sounds really nice. I like this. I also say this from time to time. We shouldn't go under our quality standards as developers, right? We should keep high quality. But at the end of the day, this is not really realistic, and this is not really the thing that matters. The thing that matters is that people want more features more quickly, right? And I think, especially for the developers, maybe the most important sentence on the slide is that economics always overcomes any statement of engineering profession at the end of the day. So if you argue why you need architecture, I found, or I personally always use this hypothesis from Martin Fowler, where he has actually two axes. He has the cumulative features, so the features we deliver over time, and we have the time. Who knows this? Okay. Only Daniel. What a surprise. Cumulative features and the time. So this is how true architecture looks like, right? So we have a lot of new features in the beginning, but we cannot really add new features anymore. And at some point in time, it's just over. I mean, we could maybe add it, but at least it's not rational anymore to add new features because it's just too cost intensive. So who was in projects like this? So many liars. I'm quite sure that everybody was in such a project already, and it's, I think, fully okay. and they still exist, and we cannot fully avoid them, I guess. But this is actually what we should strive for, right? Good architecture. And who was in such a project already? Who was in a project where he had the feeling it's really good architecture? Yeah? And this is also what Frohlan describes in this hypothesis, and I think this is fully true. I also had the feeling once that I was in such a project, or maybe two, and it's really like it is, right? You start working on a good architecture, and actually creating new features becomes even simpler sometimes. Yeah, you really have the feeling that you tackled the domain with the design of the software in such a good way that it actually drives you to push in new features in the right direction, right? So if you have to add new features, you actually know, because the architecture is fitting so good, where you need to add them. And I think this is very important. This is very important, that we need good architecture actually to deliver fast. And the other day I read a blog post from good old Uncle Bob, of course, and I think he says something quite similar. He says there is no trade-off between quality and speed. In software there has never been. Low quality means low speed always. And I think this is a big misconception, that we think if we decrease the quality, we can increase the speed, maybe for a very, very minimal amount of time, but usually that's of course not a good strategy. Another important thing when we argue about why architecture is actually important is the Devops Report. Who knows the Devops Reports? Yeah. They are really good, actually. If you're not aware of them, you can look them up. They come every year. And actually, they're big companies and organizations analyzed, and they check why are these companies performing maybe better than other companies. And I mean, this is a quite huge picture. The important stuff here is actually the software delivery performance here. And the software delivery performance survey actually consists of two parts. Of course, mainly software practices, right? So code maintainability, loosely coupled architecture, which leads to continuous delivery, which leads to good software delivery performance. And the second one is, of course, culture. So culture and software practices will lead to good software delivery performance, and this will automatically, or more or less automatically, leads to good organizational performance. And I think this is very interesting, and it even gets more interesting if you take a look at the culture, because you usually can zoom in into these graphs. And culture is actually based on three things. Actually on one thing, which is autonomy, but only autonomy itself doesn't mean culture, or doesn't bring good culture. What you usually need then is you need trust, and you need to give the people the voice, because just with autonomy you will not automatically create culture, right? And I think those two things are very important. And of course, many people know this already, right? And I think this is already back known, of course, in the Agile Manifesto. This is not really the Agile Manifesto, these are the principles of the Agile Manifesto. So I'm not sure how many are aware of the principles of the Agile Manifesto. This is just a separate page. They are quite interesting, so it's not this over that. It's really 12 principles, I think. And two of them are actually very important in this context, I think, right? So the continuous attention to technical excellence and good design enhances agile development, I would say, yeah. And this is actually a no-brainer, right? So they say actually, if you want to go in a fast way, in an iterative way, of course you need to enforce technical excellence. Yeah? And the second principle, which fits quite good in this talk, is that the best requirements and design emerge from self-organized teams, right? So this goes again into this culture area. So actually we need to have two things. We need to have good architecture that allows us to go fast, right? And we need to have autonomous teams that allow us to go fast. And that's very interesting, because actually that's somehow clashing, right? On the one hand side, you want to have an overall healthy, natural architecture. On the other side, you want to have very fast-moving, independent teams without any dependencies, right? And those things usually do not fit. And this is when people usually start to talk about governance. And I think there's one big problem with governance. Yeah, it's a somehow a dirty word. Yeah, usually you don't even talk about governance anymore. If you say governance, come on, we don't need governance. Governance is 2010. Yeah, but I think governance is by definition a very important thing in this aspect. And if I think about governance, I always think of a frame. I always think of two sides which are important in governance. The first side of governance is the one where you have control over, right? So this is your safe zone, you could think of. This is where you can independently and freely move. Right? And the second one is the one which is given. So this is the one you can maybe hardly change or maybe change, but it's very exhausting, but it takes a lot of time, and actually you want to somehow align with this. You do not want to say, hey, we need to change the if stuff all the time for me. And of course, it's very hard to find where is this boundary, when actually this boundary is given. And if you think about governance, you need then two things, right? For the thing you can control on your own, you need guidance. So it's not okay if you just say, hey, people, you have full autonomy, but you don't mentor and guide them somehow, right? So it's very important, otherwise it will be very chaotic. And the second thing is about the rules. So this is really the strict border, you could say. Yeah? It's about, hey, we shouldn't do this. We align on not doing this. Yeah? And we cannot fully negotiate one of those because both are always given. It just depends on the size of these frames. I will talk about the size of the frames a little bit later. I would just first of all start to talk a little bit about the rules, right? Because the tricky question, if we think about architectural rules, is how can we actually define rules when things change all the time, right? This is the feeling you have as a software engineer these days. Every time you come to work, there's some new surprise, and every time. And it's really hard. And how should we actually define rules on such a volatile environment, right? How do you want to define a rule in the JavaScript ecosystem or in Devops tooling, right? Things are changing every week. You cannot make rules here, really. Yeah? So how can we handle this change? Yeah? And to understand how we can handle this change, it's important to understand there are two different sides of change. The first one is business-driven change, and the second one is technology-driven change. Yeah? The first one is easy. No, it's not easy, but at least it's in a good shape, in my opinion. We have a lot of good practices, a lot of good books, a lot of good experiences in the area. So mainly all the Agile books we are thinking about the last 10 years actually handled the business-driven changes, right? So we wanted to make software more resilient to business changes. We wanted to make software in a way that we can handle business changes easily. The second one, technology change, that's actually a tricky one, and it's quite impactful. We had a discussion a couple of weeks ago. What changes actually more often, the business or the technology? Sometimes I have the feeling that technology changes more often. Yeah? Sometimes we just need to rebuild systems because we cannot support the old framework anymore, or things like this. And if you, for example, think of Docker, right? Docker changed totally how we operate our systems these days. Or if we think about fed clients with single-page applications versus request-response models, this changed totally how we architect our applications, maybe even without changing the business. So if we talk about it, I like this visualization from Neil Ford a lot, where he always says we have those requirements, but on top of these requirements, we have actually a lot of more technical things, right? People tend to call them non-functional requirements. I don't like this term because I think it's very misleading. I think it's very important that those requirements are functional. Otherwise, they will make your software non-functional. But those non-functional requirements are usually also called utilities of software because they always end with utility, right? So maintainability, usability, availability, scalability, so all those things. And what we usually need to make them as architects, so if we work in those projects, we need to find a trade-off, right? That's all it's about, right? We cannot find a perfect architecture because we can find the perfect trade-off for our use cases. So for example, if we say, okay, performance and scalability is very important for us, we will have issues with consistency maybe, right? We cannot have fully consistency. We cannot have all those dots on the right-hand side. For example, if we say security is very important for us, we will have problems if we want to have high performance. This is just not matching. Security has an impact on the performance, for sure. Security maybe even has an impact on the usability of the system, right? So, and this, if you think about this, and if you decide and if you move those dots somewhere, this is actually your architecture, right? This is what you're striving for. If you make new decisions and you said performance is the most important goal for you, then you must make in every decision you make, have this in your mind. You must have in your mind, okay, performance is actually our driving factor, right? If you want to decide, do we have a second security audit or do we have do we release very fast, right? And releasing very fast is your main characteristic of the architecture. Then you always have to keep this in mind in your decisions, right? How can we now ensure when we decide those dots that we don't just decide them on a kickoff workshop, on some kind of architectural kickoff? How can we ensure that these principles stay the same over the whole life cycle of the application? And for me, there are multiple possibilities, for sure. There's, of course, you can put it in a conference, yeah. Conference is, for me, always like a master thesis, right? You write it once and nobody reads it, yeah. Somehow the same. Or you can put it in Excels. Excels are actually quite good. Unfortunately, it's an empty Excel. But what usually people start to do is they add non-functional requirements in Excels and at least have some kind of measurement next to those non-functional requirements. They say, okay, we have a request response time from 1 second, yeah, or we have the first meaningful paint of the page in 1 second, and things like this. So this can be quite useful. So we already have some kind of definition, but what we are still missing, of course, we do not have any kind of verification. Yeah? So even if we have those Excels or those conference pages, but if I ask you, does your architecture fulfill this goal, you will not be able to give an answer because you don't have the verification. You say, yeah, I tried to tell the developers that we should go into this direction, but it's quite hard to achieve it without any kind of verification. And this is where actually building evolutionary architecture from Neil Ford, Rebecca Pearson, and Patrick Kua comes into play. And I think this is a really, really important book when it comes to architecture in agile environments. And of course, I cannot explain the whole book now in 35 minutes. I could have done it in 50 minutes, but I'm not 35. The most important thing in this book are actually fitness functions. Who knows about fitness functions? So not the ones from machine learning, because actually we also stole this term again, as usual in software engineering, we take terms from somewhere else, and this creates a lot of confusion. So it's actually the fitness functions from machine learning which gave the inspiration to do fitness functions also at an architectural level. And those fitness functions actually give us an objective about our architectural characteristics. So how does this work? Let's start with a simple categorization. So first of all, we can categorize fitness functions based on the scope. So are they very atomic or are they very holistic, right? Do they focus the whole system or do they focus maybe some kind of classes or some kind of jar or assemblies, right? And then we have the grouping. Is this fitness function triggered manually? So just when we need it, or is it triggered continuously? So on a daily basis, on every commit, on every merge, whatever. And to get you warm with this concept of fitness functions, a very simple idea would, for example, be that we hate psychomatic dependencies in software development, right? We don't like if module A depends on module B, and module B depends on module C, and module C depends on module A. Usually we really don't like this. And we don't like this for one reason, because we cannot reuse this stuff, right? Because if I want to reuse module A, I need to reuse all the other things too. And this is what actually people tend to call the gorilla banana problem, right? So you want to have the banana, you get the gorilla, and the gorilla gives you the whole jungle, right? One of the problems we usually have in object-oriented programming sometimes. And with a fitness function, you could easily solve this. Here's a code from JDepend. It's an open source tool for Java, actually, which allows you to ensure that you don't have psychomatic dependencies in your application. So it's 4 lines of code, and this problem is actually solved, right? There are a lot of tools like this. Actually, I worked a long time with NDepend. There's seen JDepend. So NDepend is the .NET port, more or less. JDepend is the open source thing, and JArchitect is the more professional freemium stuff for Java. And with those tools, you can, for example, avoid this very simply. It's just a test, so you can put it into your CI/CD pipeline, and those issues are actually solved. So psychomatic dependency check would be a simple one. Would be very atomic, so really on the low level of your code, and it can be very continuous, so you can run it every time. Another one, for example, when we come back to microservices, would be something like this here, where we say, okay, we have one contact microservice, and we have 3 consumer microservices which consume the contact from this contact microservice. So let's say we have the first microservices who requests the first and the last name from this contact microservice, and the contact microservice has a contact with 50 fields, and this first microservice just needs the first 2 fields. The second one let's say it just needs to have the age of this contact, right? It just needs to know, is it 18 years or is it not 18 years? And the server just needs to have the email address maybe. It's just a notification service which needs to send emails, so it just needs to be aware of the email address, right? And what we can do then is, we have of course the problem that the contact top microservice is hard to change because 3 services are depending on this microservice, right? So what we could do then is we could say, hey, I'm so nice, I'm the contact service. Please give me a set of tests that test my response, and I will tell you if your tests are still green, and only then I will deploy myself, right? So we provide tests, give it to the contact service, and the contact service will only successfully deploy if these tests are still green. This is what we usually call contract-driven testing, right? So we give contracts to our applications that needs to be consumed, and based on these tests, we check if we still can deploy those things, right? 2 tools. I used PACT here a couple of years ago, actually. It worked quite good. I'm not sure how active this project is, but it was technology agnostic, so you can use it actually for most of the frameworks and technologies out there. And for the Java shops, there's Spring Boot, Spring Cloud Contract, which is more or less free with Spring Boot. And what still tells you, for example, can ensure that you don't have these monolithic deployments anymore, right? Many of us, I guess, are doing microservices, but we still deploy all of them together because we cannot be sure that the different versions of microservices are working together. And contract-driven testing is a very good example to avoid those scenarios. So this would be already a very holistic, but still continuous possibility to achieve this kind of fitness function. Another one is Chaos Monkeys. Who knows Chaos Monkeys? That's a very famous one. Of course, it was introduced by Netflix. Actually, when I saw it the first time, I thought, okay, it's Netflix, it's this company with this kind of dependencies or this kind of architectures. So it's not really relevant for me. That's fine. I don't need to work in such problems or in such projects. And my projects usually have total different architectures. Yeah? And that's okay. So I always thought, I don't know, Chaos Monkeys is not something we can use in smaller projects. But actually, I was wrong. I was in Berlin a few weeks ago, and I was there at the Zalando branch, and they told me a very interesting application of Chaos Monkeys. So what they, for example, do is when they deploy microservices, they take one microservice and fully deconnect it to all the other microservices. So this microservice do not have any connection to any other microservice. Yeah? And what they then do is they then go to the Swagger files, because the Swagger file is more or less the API definition of the microservice, call all the endpoints and check if one of those endpoints just returns a 500, so an internal server error, right? Because in microservice architectures, we should be very resilient, right? Even if this microservice is not existing or not working, this one should still work. I mean, it must not fully work, but it should not return an internal server error. It should say, okay, contact microservice is currently not available, I cannot give you the contacts. Or maybe I have internally a cache, I give you an old contact or whatever, yeah? But it should not fully break, yeah? And this is what they ensure with those services. And this was very interesting, and I found out actually that's the Netflix Siminia army, this would be the conformity monkey. Yeah? So this actually, they also have this monkey who calls all the endpoints and checks if no connections to other microservices are given, no internal server errors are triggered. A second thing they do, which I also found quite interesting, is actually they use OAuth, which is a security check in automatic one, right? So for example, this library goes through all microservices and checks if the debug ports are still open, sorry. So it checks if, for example, you deploy a microservice with open debug ports, yeah? And if you have open debug ports, the build will break, or actually the deployment will break, it will kick it back to you, and you need to fix it, right? And actually this is quite helpful because we sometimes need those checklists, yeah? And we can simply automate them. Sorry. Another tool in this area would be Black Duck. It's a little bit more expensive, but it actually also does the same things for security testing. So this would be the Chaos Monkey. So we wouldn't do this all the time. We would do it at some circumstances maybe. Yeah? We'd say, okay, we will now run against those microservices if they're really secure. We will run against those microservices if they're really resilient. Another one is testing. It's really rough in time. This is actually a test pyramid. I guess everybody knows the test pyramid. It's still one of the most important and fundamental things when I talk about testing and unit testing and all the stuff, right? We know it, we need a lot of unit tests, and we should have less end-to-end tests, lots of unit tests because they're very fast. They help us very good in finding the root cause. They do not have many false positives, right? They are easy in maintenance, less end-to-end tests because they're very slow. They break very often. We do not know why they break, all those things. But why do we still do them? We still do them because on the bottom of this pyramid, we do the things right? So we check if we do the things right. On the top, we check if we do the right things. Sorry. And if you think about it, and this was just a thought I had a couple of days ago, that's why I put it in the slides, because I think it's quite interesting to share maybe. If you think about it, the bottom of this pyramid is very technical, yeah? And the top of this pyramid is very user or business driven, yeah? So we need a lot of tests which ensure that based on the business requirements, our software behaves correctly. But if we now say that actually architecture, right, so the overall architecture of a project is very important to stay fast, we should maybe think of also introducing end-to-end tests for architectural consistency, for example. And one library is here, ArchUnit. It's also in Java library. And it helps you actually a lot in actually doing this, not just checking if the cohesion of a class is good enough or if we have some kind of type checks. But it helps you really to check consistency in your architecture. And I think this is a really, really interesting approach. So if you think of a classical layered service, right? So we have some kind of controller, so we have UI logic, we have some kind of business logic in our services, and we have data logic in our persistence. Yeah? So actually most of the microservices still look like this, right? Even if we put verticalized system now internally, we still have this horizontal layers, and that's fine. And usually you want to avoid, I mean, this is one of the last things in our industry where we think we all have a common understanding. We want to avoid that somebody from the UI is directly calling the persistence, right? This is some of the things that are given. Not always. If you talk to data analytics, they usually want direct access to your database because they say, I don't want to go through your slow services, right? But usually you want to avoid this. Yeah? And ArchUnit actually provides you this possibility to avoid this. You just need to choose the namespaces, right, of your packages, and then you say, okay, we have a controller layer, we have a service layer, and we have a persistence layer. And the controller layer, for example, should not be accessed by any other layer, right? And the service layer should just be accessed by the persistence layer, and so on and so on. And this is really interesting because this helps you with 7 lines of code to ensure what we always had big troubles in, right? Ensuring that we have real horizontal layers, because we all know this, right? We are doing out-enter-driven development, right? So a namespace is missing, we click alt-enter and we have it in, right? And we can avoid it by such tests, for example. The other tools for the net, we have NetArchTest, which is actually the same thing, and for JavaScript, there's a small JavaScript port I tried to work on. Actually, I didn't have too much time, so I don't use it in production, but it's called ArchJS. It follows the same ideas and principles of very fluid APIs. Good. I always try, when I do these talks, and I did a talk last year here about microphones. Was somebody in the talk last year? Yeah, very good. That makes me happy. No, just kidding. I always try. I always try to really give information which we made as experiences. Yeah, what you see here is not something I read on Twitter or I saw some conferences. This is what really we tried out. Yeah. And to make this really clear, because I was talking a lot about microfrontends last year, and I was giving a lot of talks about this topic, and especially for microfrontends, we had a very important thing here. We had also this idea of making fitness functions for this idea of microfrontends. And for example, for microfrontends, it's very important. We do microfrontends because we want to decrease the bundle size. We want to have very small bundles. When the user visits our page, he should just get small bundles of our application. We don't want to give him the full front-end monolith, we want to slice it smaller. And one of the ideas we have here is that we, for example, with the Angular CLI, you have something which is called budgets. So you can say, okay, we have a budget for the size of our modules. So we can define, for example, a module should only be 100 kilobytes, and then it gives a warning, and if it has more than 200 kilobytes, it gives an error. This is already an enterprise application. Yeah? In a small mobile-ready application, you would maybe not use 100 kilobytes, But here you define, okay, all those applications should have those. All those applications which are actually tagged as micro frontend bundles. And if you do this, this is actually for free, yeah, because the Angular compiler does this for you, and you don't have to do anything else. Yeah? You're just configuring this. Whew. Okay, so I will I will give you, and then I will just close it afterwards. I will not go into the second area, but I would like to at least show you this example, because I think this is very impressive what GitHub did here. It's one of the best examples I so far heard about fitness functions. So GitHub had this issue, I think 3-4 years ago, that they had this problem that the merge algorithm didn't work really good. It was very low in performance, and they couldn't use the original Git merge because it didn't work for them for whatever reasons. You can read it up. And they created a new merge commit function. So this is really the merge commit function from GitHub in Ruby. And it's really interesting because it's very small, but it's actually the most important function they have, right? So it's the function which is triggered most of the time. And they wanted to exchange this. They wanted to exchange the old merge function with the new merge function. So how do you do this in such an application like GitHub where you have millions of users each day, right? And what they tried, or what they actually invented, they invented a library called Scientist. It's based on Ruby, but it's actually available as fork for every other technology. And what's really cool about it is that you can play a scientist in your application. That's why it's called like this. So I like the name a lot. And what it actually does, it allows you to make 2 branches in your application. It allows you to define a use branch and to define a try branch. Okay? And then you can configure, for example, how often you want to use the try branch. And you, for example, would configure that you want every 1% of all your requests should go to the try branch. But that's not like A/B testing. We always return the use branch, but in parallel we try the try branch. And then they did this measurements, and they found out, okay, already the performance is much better with the new code. And so they could actually get really good measurements by doing this. And then they had this graph where they showed, okay, this is the old function and the new function where they return the same values. Here in the bottom you see the errors where the new and the old function actually return different values. So it's roughly about 4 times or something like this. So it's really low errors. And then they had these comparisons between the try, which was very performant, and the old merge, which was not so performant. And actually, they wanted to achieve no mismatch within 24 hours, and they wanted to have over 10 million comparisons, right? And for me, this is the best definition of a fitness function you can have, right? You say, okay, we want that there's no mismatch in 24 hours, and if we do this with more than 10 million comparisons, we can be sure that we are safe, right? So this kind of shadow availability would, of course, be a triggered holistic fitness function. So as Andreas is already showing me post-its all the time with 0 on it. I would have loved to go into guide, because actually that's nearly the more important point. But I will do it next year, exactly. The chances are high that you find this talk on YouTube quite soon in a full version, so then you can look it up. So I will just skip it. All interesting stuff. I will just skip it. We have 20 more minutes. So coffee break. Ah. Okay, yeah, then let's dig deep. Let's dig shortly into it. So, of course, we said there are rules for the things we shouldn't change or we cannot change, and there should be guidance for things where we can work freely in, right? And it's very important that this guidance frame is not too small, and I think it's really important because we're all looking for the best developers, we're all hiring the best talents from universities, right? And then we give them a problem, right? And software engineers are nothing else than problem solvers, right? They use technology to solve a problem for you, yeah? And then they come to your company, you give them a problem, and then you say, you have this problem and you can work in this frame, right? Which is very small. And then they actually have 2 problems. And when they are smart enough, they will solve both problems, right? And they will break out of the frame because that's why you hired them to solve problems. So I think it's very important that we have a quite big frame for guidance where people can work in. Yeah? And the best book I ever read when it comes to guidance is actually a very old book. It's Extreme Programming from Kent Beck. I think it's around 2003. And it's very interesting. If you haven't read it, you should definitely read it. Even if it's old, actually, all the ideas about Agile and all the ideas about test-driven development and stuff like this, actually, I think started in this book. So it's really good. And what Kent Beck already said back then is, he said, actually, we need three things to have working environments, working teams, and working software architectures. And this is values, principles, and practices. Yeah. And the values part is very important. We should maybe call it these days strategic goal or whatever, but it should be somehow the vision where you want to strive for, right? And the principles is really the core ideas how you can achieve this vision, right? So for example, if you want to be very, very high available, the principle would be, of course, scalability, right? Scaling out instead of scaling up. Yeah? And practices are the tools that help us to achieve this. So for example, the principle would be that we build a rock-solid software. We don't want to release all 2 weeks. It's enough if we release once a month, but we want to have rock-solid stuff. Then a practice would be, for example, test-driven development. We teach the developers how to do TDD, to find the right use cases for TDD, to apply TDD correctly. And this is all in this book back then from 2003, and I always reference this. And if you take a look at the internet, you find out that actually most of the big companies follow those three things, right? For example, the Google engineering practices document follows exactly those three things. They call it a little bit different, but they all have the 3 steps. John Lewis, this is a shop I didn't know so far. They have the best engineering practice definition, in my opinion, so you should maybe look this up. It's also structured that way. And it was quite interesting for me when I read another good book, Building Microservices. Yeah? Building Microservices from Newman actually follows the same ideas. It's called a little bit different, but before we had this book, actually, we never had a real clue how big a microservice should be, right? I remember quite good when I was at the first conferences about microservices 5 years ago. Every question people ask after I talk about microservices, how big should this microservice be, right? It was always the number one question, right? And then at some point in time, Martin Fowler, I think, said it should be big enough that you can feed it with a pizza, right? And this had dramatically issues on the European side because the European pizzas are much smaller, right? So we ended up in really small nano services. And then Noahs at some point in time said, okay, microservices should fit in your head. They should be big enough that you can think about them. But this is also not a definition. But then Sam Newman brought this amazing book, in my opinion, and he said microservices are architecture that is based on strategic goals. So he called values strategic goals, and he said the strategic goals is that we are high available, that we can ship very fast, yeah, and that we can be that we can independently deploy. Yeah, these were more or less the 3 strategic goals. And based on the strategic goals, he said we have architectural principles. So he even called it principles, right? And he said, for this we want to be technology agnostic because we want to solve the problems fast in the right technology. That's why you need to be technology agnostic. And then, of course, he also introduced a few practices. For example, we should maybe communicate with the services over HTTP because then we can have distributed systems. But the point is, if I would have given any of those developers sitting here the strategic goals and maybe some of the architectural principles, you would have found out the same architecture that was evolved by microservices, right? Because it's based on this goal. If you know the goal, you will come up with the same architecture, but the goal was so fundamentally different for microservices than for monoliths that we did, of course, not think like this. We just thought, how big should this microservice be? But this was not the idea. The idea was that we have totally different goals which we fulfill with this kind of architecture. So one last thing about governance. There's an interesting thing, interesting story I want to share with you. That's a technology radar from a company called ThoughtWorks. I guess some of you at least know the technology radar. I think most of the people think of the technology radar in a wrong way. Because if I talk to people, I often have the feeling they think this is just something ThoughtWorks publishes, right? That we know what are the cool technologies we should use, right? but actually for them internally, there's a very big impact, right? For them internally, the technology roadmap is an idea based on 4 fields: techniques, tools, platforms, language, and frameworks, where they assess new tooling, right? So for example, for the technologies, they say we should actually adopt, so the technology radar is based on adopt, trial, assess, and hold, right? So adopt means that we should actually build our applications based on those things. Trial means we should actually build up resources in those things. Assess means that we should try it out. So in ThoughtWorks terms, it means they should bring it in one product they're currently working on to try and experience most of these things. And hold means actually just keep an eye on it, but not play with this right now. Yeah? And it's really important, for example, we should build new applications with micro-frontends, and we should try with chaos engineering, right? This is the thing I showed you with the chaos monkeys, yeah? People tend to call this now chaos engineering, so the group is all together under chaos engineering. So we actually showed, according to ThoughtWorks, or ThoughtWorks internally thinks like this, that they should building up resources in this area. But this is just for ThoughtWorks too. This doesn't mean that we need to do this. And I was in a project a while ago for a German car vendor, where we did exactly the same thing for them internally. So we took a look what is actually for them important, right? And we had here, you cannot read it, but we had in Adopt, for example, Angular. So Adopt was clear, we do new projects in Angular, we don't use GSF or the GSP anymore. And Adopt was also Kafka, so we built asynchronous microservices without any synchronous communication. So Kafka was given. And for example, in Child, we need to check out React, or we need to build up resources that are able to also maintain React applications. And this was really interesting. And I think this is a very, very important thing we can do as companies or as products or projects to really find out what are the new things and how should we actually try them out. Because if you have some things in assets, right, so you want to check them, you are not sure if it's a good thing for you, but in your company, if you have something like a technology radar, you will be able to assess those things and you can share this information, right? Because if one of the ThoughtWorks project tried out those things and say, no, that's not a good fit, at least not for those things, you don't need to make this experience again. So I think that's it really for now. Thank you very much. I hope this was useful. I'm here till the end of the day, so if you have any questions, just feel free to ask.